In the previous class, we have seen what the physical quantity is and what is fundamental quantity, what is derived quantities, and we have also seen the supplementary quantity. There are two supplementary quantities, that is radian and steradian, and we have seen the system of units. That is means it is getting defined in terms of CGS, FPS, MKS, and international system, or you say SI system. Today we will see that is what dimension stands for. Whatever the derived quantities we are saying, that is expressed in terms of fundamental quantities. So means what fundamental quantities comes in how many, in what number of times in a derived quantity is termed as a derived quantity, or you say so which fundamental quantity comes in how many times in a derived quantity is called the dimension of that quantity. We have quantity, and this analysis is termed as dimensional analysis. Suppose if I am talking about area, the formula we are knowing means that it is a multiplication of length into length. So if I have to find out the dimension of the area, so how we will calculate? Let's see. That is area equals length into length. So I can write it means the dimension of the area is like this: L raised to 2, or you say the dimension of L is 2. Okay, so L has two dimensions. This is this bracket, so this bracket represents the dimension of the fundamental quantity, or whatever the fundamental quantities comes is written inside this bracket. Okay, so means area has a dimension of length. Area has a dimension of 2. Area has 2 dimension of length. Okay, so suppose if I will talk about you say density. Density, you know, density is what? Density, I can write it mass per unit volume, and it is expressed in terms of fundamental quantity as, that is having dimension is mass, and this is length into length into length. So I can write it like ml. So the dimension of density, it can be written as ml minus 3. Okay, so there are number of physical quantities which of which the dimension analysis can be done. Okay, suppose if I am talking about speed, if you have to get the dimension of speed, so how you will calculate? Since you know, since the formula of speed is what? This is distance per unit time. Okay, so distance we are representing, the disturbance is representing in terms of length and having time. So you can write it as L T inverse. Okay, so this is the dimension of speed. Suppose if you have to calculate furthermore dimension, so let me write the dimension of others quantities. Suppose if you have to write the dimension of force, so first of all you have to write the formula, that what is the formula of force. The formula of force is mass into acceleration, that is mass into acceleration. We will study these all things in further classes. That is the dimension of mass, we can write it as m, and that acceleration we know that is what, this is velocity per unit time, and velocity we know that is distance per unit time. Okay, so if you have to write the dimension of the force, so how we will write it? So we can write it as m into L into T inverse, or not, you say into, we can't say, we will say this has a dimension of mass length time square. Okay, this is, sorry, time square, this is ml T inverse 2. Okay, so the dimension of force is, force you can write ml T inverse 2. And suppose if you have to calculate the dimension of the energy, so energy is what? Energy is force into displacement. Okay, force into displacement. So it can be written as, right now we have calculated the dimension of force, that is ml T inverse 2, and the dimension of displacement is L. So it can be written as ml to T inverse 2, that is, this is the dimension of energy. Okay, so how to say energy? P-N-E-R-G-Y. This is the dimension of the energy. So there are furthermore many of the physical quantities of which you can calculate the dimensions. Suppose if you have to calculate the dimension of you say work having the same dimension as that of the energy. Work is what? The formula of work, you know, that is force into displacement. Also the same dimension of work you will calculate after writing the dimensions of each of the quantity. Force, you know, that is ml t minus 2, and that of displacement is L. So the dimension of work will be as same as that of the energy, that is ml to t minus 2. Okay, suppose if you have to calculate the dimension of the pressure, so what you will write, how you will write the dimension of the pressure? The pressure formula, you know, that is pressure is equal to force per unit area, and the dimension of force right now we have calculated, that is ml T inverse 2 upon the area. You know, initially we calculated the dimension of the area, that was L2. So finally the dimension we can write, that is ml inverse T minus 2. This is the dimension of the pressure. Okay, in this way means there is a number of physical quantity of which you can calculate the dimensions. Okay, and when we talk about the unit, so you are knowing that is the unit of force is force. We are saying in terms of force, we already have seen that is mass into acceleration, and mass having the unit of what? If I am saying if I am talking about the unit, then force is what? Mass into acceleration. Mass having the unit of kg, and that acceleration having the unit of meter second inverse 2. So we can write it that the unit of force is represented in terms of kg meter per second square, or we are saying means instead of writing so many quantity, we are representing in terms of Newton. So this is 1 Newton. Okay, 1 kg m per second square is known as 1 Newton. Okay, so what means we have calculated, means how to calculate. If you have to calculate the dimension, so by this means we can calculate what is the dimension of which physical quantity, means whatever the physical quantity, if you want to calculate, you can calculate it. So what we have seen, that what we have seen that means suppose if what we have means how to calculate dimensions we came to know. So what are the what you say, what informations you are getting from the dimension formula. So means from the dimension analysis we are means this analysis is generally termed as dimension analysis, and from this we came to know that which physical quantities are involved in this and which are directly proportional and which are inversely proportional. We can also we are also came to know by this and which quantity is more affected. So you say more affected, I mean to say, suppose if I am saying that is you are calculated the formula of density that is ml minus 3. This is what, this is the dimension of the density. So if I am saying that if I am changing the length 2 times, so means density changes by 8 times. It means since length has a dimension of -3, so if I am changing the length by 2 times, so density is getting changed by 8 times. Instead of length, if we will change mass by 2 times, so density is getting changed only by, you say, density is getting affected, or you say is getting changed by 2 times only. So from here we can say that which quantity is more affected. Here means length having more impact compared to that of the mass here. And we also have seen that is what means density is directly proportional to mass and inversely proportional to length. These informations we are getting from the dimensions. Okay, so these are very usual. These things are very important. When you come across these all things, you will see the importance of means whenever we will study, whenever means in the further classes we will study that means whenever we will study we will go through these all things and these all are okay. So what means, you say what is the, if anybody asks from you that what is the application of dimension analysis, so there is an application. What is the application? That is, you say there is a means from the principle of linear homogeneity. Means what is the application? That is, it is principle of, you say, means, okay, let's see what is principle of homogeneity. Okay, so principle of homogeneity means what? Okay, say suppose I have a formula S equals ut plus half at square. Okay, so means what? Okay, what we are talking about? Principle of linear homogeneity. About this we are talking now. Okay, so suppose if you have a formula that is S equals ut plus half at squared. S is what? S is the distance displacement covered. Okay, so means, and u is the velocity and t is the time. You already came, means you already know that A is acceleration. So means if you have to say how many terms are present here, so we are saying that this is one term, this is another term, this is third term. So we can say this is 1, 2 and 3 terms are present in this formula. How you will come to know that how many terms? So means what you say the quantities means you say these whole quantities added by plus or minus and means you say these whole quantities is getting, you say will representing us, will have a same dimension, and this all will also should have a same dimension, so that means this will equal to of this.